Hello students, today we are going to learn ionization energy. Yes my dear students, one of the important periodicity of periodic table. So in the periodic table we may study some properties will vary according to the atomic number. Okay, so the first property of periodic table, already we have studied about atomic radius, the same way ionization energy. What is ionization energy? The minimum energy required to remove an electron. What is the minimum energy? Why we want to remove? In case if you take one atom, in that atom, suppose you are going to remove an electron from the valence cell, because we cannot remove from the inner cells, we can remove only from the valence cells. If you remove the valence electron, we want to give some energy. That giving energy, that required energy is called ionization energy, right? So from an atom, if you remove the electron, we want to supply some energy. That energy is called ionization energy. It is also called ionization potential. Wherever we are using IE, we have to remember that is nothing but ionization energy. It is also called ionization potential. Okay, my dear students. Yes. So as per the book definition, how will you define ionization energy? Ionization energy can be defined as the minimum amount of energy required to remove one electron from the loosely bounded electron from the valency cell of an isolated gaseous atom in ground state is called ionization energy. What is the ground state? What is isolated atom? Again I am telling my dear students, the minimum amount of energy required to remove an electron, that is loosely bounded electron, from its valence shell of isolated gaseous atom in the ground state is called ionization energy. One by one we will tell. Okay, actually concept, amount of energy required to remove electron. What type of atom we are going to take? Ground state atom. What do you mean ground state atom? There is no electron present in excited state. What is ground state? What is excited state? Is there already some energy applied? Because of that energy, some electron may be jumped from lower energy level to higher energy level. That excited state not applied. Ordinary element, that is called a ground state element. In the ground state atom, it should be a gaseous atom. What do you mean gaseous atom? We know that solid, liquid and gaseous. So where we are going to remove the electron, that atom should present as a gaseous atom. And also it should be the isolated atom. What do you mean isolated? It may not be present as a compound. For example, sodium chloride, silver bromide or potassium chloride, copper sulfate. Like the atom should not combine with any other atom. It should be isolated like neon, argon, krypton. It should have the single atom, that only called isolated atom. What are the conditions we have to apply for that atom? It should be isolated, it should be gaseous, it should be ground state, right? That atom, from that atom we are removing some electron from the loosely bounded electron. Loosely bounded electron means which is not having high force of attraction with the nucleus. What do you mean high force of attraction between the nucleus? We know already nucleus having positive charge, electron having negative charge. That positive charge will attract the negative charge towards itself. So because of that, electrons are revolving around the nucleus. Yes, in that last cell, that means valence cell, we already know that, which will have less force of attraction compared with the inner cells. Because of shielding effect, we know that. Or the new cells are produced means the distance between the nucleus and the outermost cell increases means which will decrease the force of attraction between the nucleus and the outer cell. Okay, right. So because of that, it may have loosely bounded electron. The valence cell Electron always having the loosely bounded nature. Loosely means it's not having more force of attraction between nucleus and the electron, right? So what is ionization energy, my dear students? The amount of energy required to remove an electron from, what are the conditions we want to apply? Gaseous atom, isolated atom, and it's present in the ground state, right? If you found that energy that having some unit, okay, we can measure with some unit. What are they? Kilojoule per mole, first unit. Also we can measure with the electron volts, right? EV means electron volt, small e capital V, right? Kilojoule mole inverse or electron volt we can use as a unit for ionization energy. So as an equation, how will we explain the ionization energy? For example, any atom we will take, that is written as a M. It may be indicated metal or atom, right? So some metal or element we will take, that is indicated with the M. We are supplying some energy, that is ionization energy. Required energy means we are applying, that supplied energy is indicated ionization energy. What do you mean one? One indicates first ionization energy. What do you mean first ionization energy? The ground state element, we are going to remove electron initially. Previously, it don't have any charge, positive or negative charge. That means first time we are removing one electron means that is first ionization energy. In case we will learn the successive ionization energy also. See, IE1, IE2, IE3. That means already we removed one electron. Again, in the cation, we are removing one more electron means that is second ionization energy. Likewise, we will learn what is successive ionization energy. Okay, right. So IE1 means first ionization energy. We are applying this energy. We will remove one electron. After removing, the atom will carry positive charge. Why positive charge? Loss of electron. Already in the previous class we have studied removal of electron becoming cation, addition of electron, gain of electron becoming anion, because gain means it will carry the negative charge, loss of electron means a positive charge, right? So because of this removal of electron, M carries positive charge. Okay, my dear students, right? What do you mean successive ionization energy? Successive means next to next, right? Already we have removed one electron from an isolated gaseous ground state atom. In that we are removing one more electron means that is called second ionization energy. Look at the board, my dear students. The minimum amount of energy required to remove an electron from a unipositive cation. What do you mean unipositive cation? Plus one charged cation. Plus means cation. Plus 1 means unipositive. Plus 2 means dipositive. Right? So unipositive means like this. Already it is an unipositive cation. From the unipositive cation, we are applying again some energy. That is second ionization energy. Because of this applied energy, we can able to remove one more electron from the same. That is M plus. Okay. Already M neutral state. Now M plus means first time we have removed one electron. Again from the unipositive cation you are applying the energy, that is called second ionization energy. If you remove one more electron, the plus 1 will increase it into plus 2. So M2 plus and one more electron is removed. So this is called second ionization energy. Actually I have written the black, that is a definition for second ionization energy. What is second ionization energy? The minimum amount of energy required to remove an electron from a unipositive cation is called second ionization energy. Likewise, we can go with the third ionization energy, fourth ionization energy, fifth ionization energy. It will go like that, right? So, first ionization energy, second ionization energy over. If you compare which energy may more, which energy may be less. For example, first ionization energy, second ionization energy. Which one may require more energy? First ionization energy or second ionization energy? Second ionization energy will becoming more because see here already you removed an electron, so less number of electron but same nuclear charge. What will happen? Nuclear charge high, number of electron less, so it will attract more effectively than neutral atom. Because of that reason, again if you going to remove one more electron from the same element, what will happen? You want to apply more energy than the previous one. That's why if you compare the first ionization energy and the second ionization energy, second ionization energy will be more than the first ionization energy, right? So if you compare all the successive ionization energy, what will happen? The first ionization energy will be less than compare with the second one. If you compare second and third will be the more compared with the second one, right? So the successive ionization energy will increase like this, right? Reason also I have written. See, number of electron decreases. How the number of electron decreases? We are removing one by one, you know. So number of electron step by step. Each ionization energy will remove one electron. So number of electron will reduce or decrease, right? But what will happen? Same nuclear charge will possess or it will attract the electron. Because of same positive charge or same nuclear charge, the attractive force between the nucleus and the electron will be increased. Because of increase of this force of attraction between nucleus and outermost cell, we want to apply more energy in the successive ionization energy, right? So number of electron decreases, but what happened? Same nuclear charge exists. Because of this reason, successive ionization energy will increase, right? Now we are going to apply this ionization energy in period wise as well as group wise, right? So first we are going to check what happened in the period wise. You can remember here already we have discussed about size. Yes or no, my students? Yes, right? What will happen in the period wise size? It will decrease. What is the reason? From left to right, period wise size will decrease. What's the reason? Electrons are added in the same cell, but nuclear charge, protons also increases in the same time. Nuclear charge will attract more effectively. Because of that, size will decrease from left to right. The same reason we can tell here, because of size decreases or electrons are added in the same cell, but nuclear charge increases. How the nuclear charge increases? One atomic number increased means electron will increase as well as proton increase. Proton increases means nuclear charge will increase. But electron also increases, yes, but it is added in the same cell. So the distance between the nucleus and the outer cell becoming same. So nuclear charge increased same distance, so it will attract more effectively. Size will decrease. Here you have to note the point, my dear student. The size decreases means the distance between the electron, the valence cell electron and the nucleus becoming less. Distance less means it having more force of attraction between the nucleus and the outer cell. More force of attraction means easily you cannot remove the electron. For example, what is the duster? Yes. If you compare small atom, large atom, we are going to compare. See, in period wise what will happen? Small size means the distance between the nucleus and the outer cell becoming small. Small means force of attraction high. High force of attraction between electron and the nucleus. But what will happen? The distance between the nucleus and outermost cell becoming larger. Larger means what will happen? Less force of attraction between these. So is there one electron means by applying less ionization energy, we can able to remove an electron. So size decreases means ionization energy also will increase. Size increases means ionization energy will decrease, because by using small energy we can able to remove in the larger atom. So here in your book itself you can write one formula. Actually it is given in the old 12th book. What is that? Ionization energy, simply I can write IE, is inversely proportional with size. Size decreases means ionization energy will increase. Size increased means ionization energy will decrease. So ionization energy inversely proportional with the size. Here we can keep in mind, right? And also we can read the book definition or book explanation. Ionization energy in period increases. This is very important one mark. Ionization energy in period wise. Period wise means left to right. Left to right, what will happen? Ionization energy will increase. Why increases? Electrons are added in the same cell, but nuclear charge increases because of addition of a proton. So more energy required to remove electron because of more force of attraction between nucleus and electron. So left to right, what will happen? Ionization energy increases. What is the reason? Nuclear charge increases, but same cell electrons are added, right? So next we are going to learn about graph. We are going to draw a graph for second group elements in the period. Second period, what are the elements are present, my dear students? Who will tell? Within this rubbing gap you can tell what are the elements are present in the second period. Shall I? Yes. Lithium. Then lithium, beryllium, boron, carbon, oxygen, nitrogen, fluorine, neon. Okay, my dear student, left to right. As you know very well, which one having more ionization energy? Neon, right? So because size decreases, which one have least size? It will have the more ionization energy, right? So if you compare this one, the last one will have high energy, first one will have the least energy, least ionization energy. So you can draw a graph. In the x-axis you can take atomic number. What is this? Atomic number. You can take like 1, 2, 3, 4, 5, 6, 7, 8. Likewise it will go. Here you can write the ionization energy. IE value 500, 1000, 1500, then 2000. Likewise, if you draw and graph in this, what will happen? As per book they are given lithium, then beryllium will increase, then boron somewhat will decrease, again carbon, again oxygen, nitrogen. 1 minute, my students. Nitrogen becoming higher. First, what is this one? Lithium, beryllium, boron, next to boron, carbon, next to carbon, oxygen, next to oxygen, nitrogen, next to nitrogen, fluorine is there, so fluorine little bit decreases, finally neon, right? The symbols they didn't mention in your book, even you can write like this: lithium, beryllium, boron, carbon, oxygen, nitrogen, fluorine and neon. See, increases from left to right. Now you should have like this graph. Are you able to follow, my dear students? Lithium, beryllium, boron, carbon, nitrogen, oxygen, neon, likewise fluorine, neon. You should have like this. But we have some up and downs. Why these up and downs? That reason we must know. So some exceptions also there, my dear students. In the period wise, if you learn the ionization energy, usually left to right ionization energy will increase. There is no doubt at all. But there are some exceptional. What are the exceptional? Boron, that beryllium and nitrogens are the exceptionals. Beryllium and nitrogen. Why beryllium and nitrogens are exceptional? Beryllium having completely filled, sorry, completely filled ionization energy. Completely filled electronic configuration. EC means electronic configuration. Here also nitrogen half filled electronic configuration. Why completely filled, half filled having highest energy? There is a two peaks, first peak, second peak. Why these two peak? That means it's having abnormal high level ionization energy. Because of that, we are getting this peak. Okay. What is the reason? Beryllium. What is the atomic number for beryllium? 4. 4 means how do you write? 1s2, 2s2. All orbitals are filled nature. S means one box. It can fill with 2 electrons. The same way 2s. So completely filled electronic configuration. Because of this reason, beryllium having high ionization energy. Then boron. Actually, next to the beryllium, boron is present. If you compare beryllium and boron, which one having highest ionization energy? We are expecting boron, but actually beryllium having highest ionization energy than boron. What's the reason? Beryllium incomplete electronic configuration. Incomplete electronic configuration means partially filled, right? Which is not having completely or half filled. According to Hund's rule, the orbital completely filled or half filled means which is more stable. Remember, my dear students, the orbital completely filled or half filled means which having more stable because inert gases completely filled nature. So completely filled means it will have more stable. Because of that, we need to supply more energy to remove electron. So beryllium having the more ionization energy than boron. The same reason we can tell. Next to nitrogen, there is a fluorine. If you compare nitrogen and fluorine, which may have the more ionization energy, left to right. See, left to right means next to nitrogen only fluorine present. Next to nitrogen means it should have the more ionization energy than nitrogen. Yes or no, my dear student? Nitrogen next to fluorine. So fluorine should have highest ionization energy. But in fact, what happened? Fluorine having less ionization energy than nitrogen, because nitrogen also having the another stable character, that is half filled electronic configuration. Now I can give the values of ionization energy also. Yes, what is the ionization energy of beryllium and boron? Beryllium, boron. Beryllium is given 899 kilojoule mole inverse. What about boron? Only 800 kilojoule mole inverse. So, according to our theory, left to right, ionization energy will increase. But next to beryllium only boron present. But because of completely filled nature, beryllium having highest ionization energy than boron. Yes, another exception also I can tell now. Here you can remember the electronic configuration also, 1s2, 2s2. Here atomic number 5, 1s2, 2s2, 2p1. Even though one more electron is present, because of complete nature having highest ionization energy. The next one is nitrogen and fluorine. What is the ionization energy of, sorry my dear, oxygen and nitrogen? We are going to compare oxygen and nitrogen. Nitrogen having more ionization energy. We can remember, my dear student, the second period elements: lithium, beryllium, boron, carbon, next to carbon nitrogen, oxygen, fluorine, neon, right? So next to nitrogen we have the oxygen, right? Oxygen only having less compared with nitrogen. That's why oxygen having less ionization energy than nitrogen. What's the atomic number of oxygen? 8. 8 means 1s2, 2s2, 2p4. What about nitrogen? 1s2, 2s2, 2p3. Right? If you draw the orbital diagram, S2, 2 electron, 2s2 also having 2 electron. P means it will have 3 boxes, so each one, right, half filled. Totally it can occupy 6 electron. In that 6, 3 is filled, so half filled nature. Because of half filled nature, it is also having stable electronic configuration. If you compare here, the p orbital may have partially filled 1, 2, 3, 4, which is not half filled or completely filled, which is called a partially filled electronic configuration. Partially filled means which not stable one compared with the half filled. So because of this half filled nature, nitrogen are having highest ionization energy than oxygen. Two exceptional, my dear student. One is beryllium and boron. Beryllium having high because of complete nature. Second one, nitrogen having high compared with oxygen because of half filled nature. Right? Now we are going to compare group wise ionization energy in group. Period wise we are completed. Period wise what will happen? Left to right, ionization energy will increase. Group wise ionization energy in group, what will happen? Decreases. Ionization energy in group decreases. Group means what? Vertical columns, top to bottom, ionization energy decreases. Why is that decreases? We know very well. What's the reason? New cells are produced. New cells are forming in the vertical column. We can take this first column, first group. What is the first group, my dear students? Lithium, sodium, potassium, rubidium, cesium, then francium, right? Fr. Lithium, sodium, potassium, rubidium, cesium and francium. This is called the first group element, group 1. If you compare the ionization energy top to bottom, the top one having the highest ionization energy, one by one it is decreases. Francium having lowest ionization energy. Why means top to bottom ionization energy decreases. Why decreases? If you compare lithium having 1s2, 2s1. Sodium having 3 cells. So then potassium having 4 cells. So because of new cells are introduced in each period, vertical columns, if you compare the ionization energy, because of new cells, lithium having highest ionization energy than sodium, sodium having highest ionization energy than potassium, likewise top to bottom ionization energy decreases. Remember, my dear students, ionization energy in periods increases, ionization energy in groups decreases. Periods, what's the reason? Electrons are in the same cell, but In the groups, new cells are forming. Because of the new cells, ionization energy top to bottom decreases. Here also we can plot a graph for this first group elements. Here as usual atomic number. So we can actually we need to write more number of atomic number. So we can take 5, 10, 15, 20, 25, 30, right? In your book they are taken 10, 20, 30, 40 like that. Here ionization energy also 300, 400, 500, 600. Okay, what's this one? Ionization energy. Shall we draw the graph, my dear students? Lithium. Actually, from top to bottom we have to draw lithium, then sodium, then potassium, rubidium, cesium, francium. So, previous graph we can remember, my dear students, it goes up, right? Because of ionization energy increased. Here ionization energy decreased group wise, so it comes downwards, right? Lithium, sodium, potassium, rubidium, cesium, francium. So group wise ionization energy decreases. Okay, my dear students, the last one, shielding effect. What is shielding effect, my dear students? Inner cell's electron hiding the nuclear charge. Because of hiding nuclear charge, it decreases the force of attraction between the nucleus and the outer cell, right? That shielding effect also influence in the ionization energy. How the shielding effect affect the ionization energy or influence in the ionization energy? Shielding effect. Shielding versus ionization energy, right? Here also we can write one short formula, my dear students. Ionization energy also inversely proportional with the shielding effect. Why, my dear students, are inversely proportional? Shielding effect increased means what will happen? The force of attraction between the nucleus and outermost cell will decrease. So easily we can remove the electron. Less shielding effect means we need to apply more energy to remove electron. Here we can take one example. This is a nucleus, right? Suppose we are going to remove electron from this valency cell. Okay. Because of this inner cell electron, here also there are some electron which will give some repulsive force. Because of this repulsive force, the force between this nucleus and the outer cell becoming low or less. So it will hide or it will shield like a shielding. The inner cell electron will hide the nuclear charge. Because of this screening or shielding, less energy only attracting the electron. Then we are learning about ionization energy. Ionization energy means the amount of energy required to remove an electron. Suppose you going to remove this electron, we need more energy or less energy? Less energy we needed. Why? Already this inner electron hided or shielding some nuclear energy. So less energy only attracting this electron. Easily we can remove by applying low ionization energy. By using the low ionization energy, we can remove. So shielding effect increases means ionization energy, required energy will decrease. Shielding effect, which having less inner cells, for example, only one cell is as an inner cell. We want to remove this electron. Here we don't have any repulsive force, only one inner cell is there. So compare this with this previous one, which have much force of attraction between the nucleus and the electron. If you compare these two atoms, which having more shielding effect, so less ionization energy needed. But in the second case, we need more ionization energy. Why more ionization energy is needed? because the force between the nucleus and electron is high. Because less shielding effect. Shielding effect is high means less energy is needed. Shielding effect less means more energy is needed. Because we want to break the force of attraction between this nucleus and the electron. That's why I gave this small formula. Ionization energy inversely proportional with the shielding effect. Shielding effect increases means less ionization energy we need. Shielding effect less means high ionization energy we want to apply. Okay, my dear students, today we have seen about ionization energy. What is ionization energy? Unit of ionization energy. What is second ionization energy? Successive ionization energy. Period wise, group wise. What about shielding effect with the ionization energy? I hope you all understand. Thank you.